Good morning, this is Timmy. Today we are going to talk about displacement and velocities in 2 dimensions. So far, you've learned about what motion in 1D. However, that's not enough to describe motions in real life because the motion in real life are in 2D. For example, car and buses do not always move in a straight line. They change directions constantly. In this lesson, you'll learn how to combine vectors to describe the resultant displacement of an object. This is very important because it will lead up to our final goal, which is to find 2-dimensional average velocity. So let's quickly begin with our first example. Look at this problem. An airplane moves 100 kilometers at north 30 degree east in 10 minutes. Then it moved 300 kilometers south 20 degree east in 30 minutes. So what is the average velocity of this airplane? When you see a problem like this, first thing to do is draw 2 separate vector diagrams for each of the displacement vector. So what does the question ask? The question asks for the average velocity. As you learned in lesson 1, to find the average velocity, you must find the resultant displacement first. To find 2-dimensional displacement, you must resolve both the displacement vectors given into their rectangular components. Let's denote the first displacement as d1 and the second displacement as d2. The x component of d1 equal to d1 cos theta and y component of d1 equals d1 sine theta. The same goes for d2. After resolving, we can actually write vector d1 and vector d2 in the form of a Cartesian vector, which is a square bracket containing the x and y components. Now finally, we can add these 2 vectors up. The resultant displacement vector equal to d1x plus d2x and then d1y plus d2y. This is the resultant displacement vector. Bear in mind that displacement is a vector quantity, so it's not the end yet. Remember, it requires both magnitude and direction, so we have to find those first in order to finish up the question. In order to find the magnitude and direction, let's now draw a new vector diagram for the resultant vector. This is the x component and this is the y component. To find the magnitude, you have to use Pythagoras theorem. Magnitude of resultant displacement equals x component squared plus y component squared. And then square root of the whole answer. Substitute the value and you'll find the magnitude is equal to 299.3 kilometers. So now what's left? Yeah, you're right. The direction of the resultant displacement. Use trigonometry to find the angle because the angle used the direction. Tangent theta equal to y component over x component. Then it is equal to 50.79 degrees. As you have learned in lesson 1, quadrant bearing must be measured with respect to north or south. But the angle you found is now measured with respect to east. Therefore, you have to use 90 degrees, subtract the angle, and you'll find the angle that is measured with respect to south. Finally, write down the final answer including both magnitude and direction. That's all for this lesson. Hope it helps you.